Welcome to the experimental video for Experiment 1. Brought to you by the University of Pretoria.
Hello everyone, just a small correction from the pre-practical lecture video on Experiment 1. In there I emphasized weigh by difference. This is not as necessary as I initially thought. Hence in the video you'll see I'm going to tear the scale to weigh the carbon, and that is also perfectly fine. So please do not try to weigh by difference. The carbon is very static and it will get everywhere if you try to weigh by difference, transfer it from one beaker to the next. So it's simply easier and you're going to solve a lot of gray hairs, and a lot of people, or a lot of carbon waste will be saved if we simply tear the scale. So yeah, please just make a small note of that. It's really a small thing. So you won't be weighing by difference. Just work accurately to 1 gram as possible. Depending on which scale you use would depend on the accuracy that you're able to, but at least 1.00 should be sufficient. And as I said, the carbon is very static, so do not beat yourself up if there's carbon to the sides of your flask. Just make sure that when you transfer the acetic acid into the flask, then you wash down the carbon to the bottom, and that you record the correct weight from the beginning, and make sure that each of your 7 flasks contains at least around about 1.00 something grams, not really 1.1 grams or too much different from 1.00. Okay, thank you. Enjoy the video.
Hi everyone, and this is now how to weigh your activated carbon for experiment 1, the adsorption of acetic acid. You will place your 250 milliliter LMI flask on the scale, and you are going to press the tear button. There's the tear button. Okay, that's open. There we go. And we've moved it to 0. Okay. Now you're going to carefully add the activated carbon to try and get as close as possible to 1 gram. Okay. Okay, that's about one of these spoons is about 0.75 grams. Flattened, not heaped. So now we just need to be very careful. And okay, we're actually exactly at 1.00. So there you can see on the scale, 1.00 of activated carbon. There's a bit on the sides. That's fine for now. Okay. So now remember, you need to prepare 7 of these. So the first one we prepared for 1 gram. So please, when you're going to weigh, just ensure that every one of these 7 flasks contains as close as possible to 1 gram. As we did for the first one. Good. And make sure that you label your LMI flask so you keep track exactly of which one corresponds to which weight of carbon or mass of carbon, and then subsequently which one is going to contain which concentration of acetic acid. Okay, so the next step is you're going to add the 100 milliliters of the different concentrations of acetic acid to your LMI flasks. And an important part of that is that what I have to show you is how the different suckers work for your pipette. So you get one that looks like this, and you get one that looks something like this. How the one works with the bulb is you have to press in the A, and then you're going to deflate the bulb as much as possible. Release the A, then you see the bulb is still in where it is. Then you will place it onto the pipette, so meaning this is the part below the bulb, and this is your pipette's top side. So not the side that's pointy, the side that's on the top. And you're going to press it in there until basically it cannot anymore. Okay. And the same idea corresponds for the other sucker, technical term, not really. You place it in there. Oh, sorry, you just need to press this down. Place it in there, and you're going to use the wheel to suck up your acetic acid. You see there, when you're turning the wheel, the thing comes out. I don't know what that's called, the ratchet. Okay, so next we're going to suck up our acetic acid into our pipette. Okay, so now we look at the different concentrations of acetic acid. We see we have 7 different concentrations as listed in your practical manual, which is going to correspond to your 7 different Erlenmeyer flasks. So that is why we numbered them at the beginning. So you're going to add 100 milliliters of each of these to one of the Erlenmeyer flask. So meaning 100 milliliters of the 0.5 molar acetic acid solution to Erlenmeyer flask number 1, and then 0.4 molar to number 2, etc., until you get to the last one, which is 0.03 molar. So first you are going to transfer your specific acetic acid solution to a beaker so that you can easily pipette. Please do not place or put the pipette into the made up solutions. Also make sure that you have enough in the beaker so that your pipette doesn't run, or that you don't have enough for 100 milliliters. So this is a 100 milliliter beaker. Please make sure that it's nicely filled. Then you're going to take your pipette and you're going to press the S if you're using the bulb sucker. And you see there the solution is starting to fill up the pipette. And remember, your pipette is marked. Here at the top, there's a very thin line that indicates that it's 100 milliliters, because this is a 100 milliliter pipette at 20 degrees Celsius, roughly. You might have to re-induce the vacuum at the top. You just do that in the same way we showed you earlier. And you keep on going until the bottom of the meniscus is on top of that thin little line there. Luckily, you would have more hands than poor old Joel here, so you'll be able to, someone can fill up the beaker should it be necessary. Okay, and then there we go, just a little bit. You can also eject using that bulb at the top to ensure that you get exactly to the meniscus point that we require. Okay. Now you need to transfer this to your Erlenmeyer flask. So remember, we used the 0.5 milliliters, and you're going to press the E for eject. There you go. Also, if you accidentally spilt any of the acetic carbon, you can wash it off now using the pipette. So very importantly, you see the activated carbon is not really dissolved. It's not dissolved in it because we're looking at adsorption, not absorption. Okay. Also make sure that you get out every last drop of your pipette, because of course we're looking at specific concentrations. All right. Okay, so now the experimental guide says you need to cover your Erlenmeyer flask. You can give it a bit of a shake just to make sure that there's nice coverage everywhere. And you're going to cover it with parafilm. Parafilm is, it's going to say something like this, which is parafilm. And you're going to cover it as such. Remove these things, the paper coverage, and you can twist it a bit, make sure it sticks nicely to glass. And yeah, now all that's necessary is we need to transfer it to the 25 degrees Celsius water bath for 1 hour. As you can see, our 25 milliliter or our 100 milliliters is in the 25 degrees Celsius water bath, secured with a clamp. Just make sure that you know exactly which, so this is why you also label, so that you know which flask is still which flask since you've transferred it. Ensure that it's nicely fastened and that your entire solution is below the water level. So you can see the water level is about there. Our solution is much, much lower than that. And what is this? If you do not know, please relook the pre-prac lecture. Okay, it's been about 5 minutes in the water bath, and it says shake periodically. About every 5 to 10 minutes. You don't really have to be very specific with this step, but you take it out, give it a good stir, because you'll see it's sort of like a sedimentation that takes place. The activated carbon settles at the bottom of the flask. And this is just to make sure that you always have optimal contact and surface coverage during your adsorption process. Okay, then you refasten your flask and you leave it again and shake a while after. While you're waiting for your hour to pass, you need to standardize your acetic acid solutions. For that, you're going to use the auto dispenser, which is this instrument here. Of course, you need to choose the appropriate concentration of sodium hydroxide, either 0.5 or 0.1 molar. And we'll show you in the next step how you're going to use it to standardize your solutions. This is a much more accurate way of standardizing than titrating by hand. So, yeah, I hope you're going to enjoy this part. Okay, everyone, so we have now prepared around about 25 milliliters of the 0.5 molar acetic acid solution in a 250 milliliters Erlenmeyer flask. And now you're going to add about 2 droplets of your phenolphthalein indicator. Ooh, that's a bit much. That's okay. Now we're going to titrate. So at the beginning of your titration, you've added a stirrer bar. You're going to switch it on and just make sure that it has a nice stir. Also make sure that your dispenser is located round about in the middle of the flask, not to the side, so that your the sodium hydroxide solution pours directly into your Erlenmeyer flask. Okay, now Joe is going to show how to use the instrument. So first you press the volume that you want, and you're going to add about 22 milliliters for the beginning, and say enter. Then it's going to show 22 milliliters on the screen for you, and you press go. Then the dispenser is automatically going to dispense 22 milliliters for you. The reason we are using 22 milliliters is because we calculated our required volume as roundabout, or estimated volume, as 23.96 milliliters. So we start at 22, and then we're going to incrementally increase the volume 0.02 milliliters at a time. Otherwise we would have been here forever. So we skipped a few. The mode is important. I'm not sure what you're saying, Joe.
The mode of the instrument should be this C.
This C, okay. Then we've dispensed to 22 milliliters of the 0.5 sodium hydroxide solution. Now, you say again, volume.
Volume, smaller addition of 0.02.
So we see there's 0.02.
Then enter.
and enter.
Then check it again by pressing the volume button. Then that's what it specs. Then you can press. When you press go, it just one drop and it shows there.
Okay.
So we just keep on adding.
And already we're starting to see every time the drop is added, the color change is remaining slightly longer. Okay, there we start to see it's starting to remain much longer than previously. We're starting to reach the end point. And now we see there's little droplets there on the side. So just make sure that you wash that off with some distilled water. Because remember, that's not going to change anything in terms of the number of moles contained in your solution. We're really close now. Actually, almost there. You see there's a slight pink. A very slight pink. Okay. I think we're happy. So we've titrated and we got 23.58 milliliters of 0.5 molar sodium hydroxide solution to standardize our 0.5 molar acetic acid solution. Remember, 25 milliliters of this solution. Okay, our mixture has now been in the water bath for an hour at 25 degrees Celsius, and you will see this is number one, our 0.5 molar acetic acid to adsorb onto the activated carbon. So now we're going to show you how to do the vacuum filtration. So you're going to use, this is your sintered glass funnel. It looks something like that. And the adapter to put onto the vacuum. It goes into each other like that, and I'm going to place it onto the vacuum. Just be careful.
A flask.
Yes, into the flask. And just be careful because remember there's no clamps here, so perhaps you must someone can hold the flask while the vacuum is on. Okay, remember to stir your solution or your mixture before you're going to discard it, and we're going to discard the first 10 milliliters of this filtrate. That is round about halfway into your glass funnel, which you'll see just about now. So it's not switched on yet because you want to discard this piece. You want to make sure you're using the right amount. So you see it's about halfway to the top of the glass sintered funnel. Okay, now you're going to put the vacuum on while holding it nice tightly. Okay. You might experience that it sucks a bit of air. Just make sure that the seal at the top, the rubber band, is then nicely pressed against the sides of the adapter, and you'll get optimal suction. And remember, always be patient. Chemistry is a patient science. Don't rush anything. Okay, so your first 10 milliliters have been filtered. Now you need to close the vacuum. Remember to always keep it secure, just to make sure nothing falls over because you're working with glass.
Then they carefully remove this.
There we go. So you remove the top part and just place it there. Okay, and now you need to discard this part, or this filtrate, this first 10 milliliters of filtrate. Okay.
To the sides.
And make sure that you get all the filtrate that you've filtered, just to make sure there's no errors in your data. Okay. discard it into a waste beaker. And make sure that you know that beaker is for your waste and not something important. Okay, so before you filter, you need to ensure that you've marked your your Buchner funnel, because you're going to be provided with 7 of them, because each of them is going to have kind of filter a different concentration, and you don't want to have cross-contamination between your different samples. So clearly mark it as number 1 to correspond with our number 1 that we've prepared today. Okay, after we've discarded our first 10 milliliters of filtrate, remember to mix your mixture again, and now we're going to pour the rest of it, which you're going to use later for your analysis, and filter that through your Buchner funnel. Okay. Secure it, open the vacuum, and you can also assist it a bit if it struggles to create a complete vacuum by pressing on the side of your glass scented funnel. There we go. Okay, and you just continue this until you have filtered all of your mixture and all of it is contained in your Erlenmeyer flask. So we've now completely filtered. We've filtered all of our mixture, and please, unfortunately you cannot rinse out the mixture, because that's going to alter your concentration then of your acetic acid that's left after adsorption. You need to remove all the components. Remember, please just be secured, there's no clamps. And then we're going to move on to the standardization. So after you've now done filtering, we've marked a second beaker called 1B, so meaning after it was filtered. So it's number 1's filtrate, which you need to clearly mark. You'll also be supplied with another Erlenmeyer flask to do this. There will be enough for you to clearly label all your flasks that you require. Okay, after you've filtered, you need to pipette 25 milliliters of your filtrate into your clearly marked Erlenmeyer flask. So we've showed you how to pipette already, but just once again to cover some of the steps. There you go, remember where the meniscus needs to be, exactly. And transfer this, you can do it directly from the Buchner funnel to 1B, which is means it's the filtrate of the first adsorption. Okay. Okay, so we have our 25 milliliters of filtrate there. You're going to add your stirrer bar to it, and you're going to add 2 drops of your phenolphthalein indicator to that, and that should be enough for our standardization, which again we will do on the instrument. Remember, previously we used so we're still using a 0.5 molar sodium hydroxide solution, because we're working with the 0.5 molar acetic acid solution, so it corresponds to a similar concentration. And previously we programmed the instrument to use 22 milliliters as our bulk dispensation. So now we're going to use 17, and the reason is just that we started lower because some of the acetic acid has been adsorbed. So just to go through it again, you say volume 17, enter, then you say volume, you check, there it says 17, and then you are here. You need to ensure that your dispenser is in the middle of the Erlenmeyer flask, your stirrer bar is switched on, it stirs at a nice constant speed, and then you press go, which will dispense 17 milliliters of the sodium hydroxide solution as a starting point. You can see there's no change, and we're about at 10 milliliters, so it means we're on the right track, searching for our end point. Okay, now we're going to incrementally insert 0.2 milliliters again, as we did for the standardization of the pure acetic acid solution. So Again, you press volume, 0.02. You check that it says that it will dispense that. You say enter. So it enters it into the machine. You just check the volume again, that it's shut, and then you say go, 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 1,000,000 times until you reach your endpoint, as we saw in the previous video.
Just have to be patient.
Yes, patience is the key to chemistry. If the instrument does this, it just means that it's refilling its dispenser from the bottle. It doesn't mean you broke anything. Also remember to rinse the sides of your Erlenmeyer flask just to ensure that all your sodium hydroxide is in the solution, and then you continue again. You're always looking for this arrow. It should appear there, and it's ready to dispense. Okay, so we're nearing the end point. You can see it takes longer for the color, for the light pink to disappear. Poor Joel's back is giving in. You can't. There we go, we're very close now. Okay. Okay, so that's around about our second endpoint, or meaning after adsorption. And please note the volume. So you're going to use this to calculate how many moles were adsorbed onto the 1 gram of carbon.
That is it for this experiment. Thank you for watching.